So here are the written questions. This is the truth table for the 2-to-1 multiplexer. And here is the 4-to-1 multiplexer schematic. These two have the same inputs. That one has a different S input. And then A, B, C, D, you know the questions 2 and 3. First up, we have the NOT gate. This one, here is the in. We have it as a high right now, and then we get a very low out. When I make the in low, the out becomes a high. Next up, we got the AND gate. Here we have both A and B high, out becomes high. And then if I make A low and B stays high, out becomes low. And then B low, it still stays low. And then when I put A high, the out becomes 2.15, which seems kind of high, but this is the most sense that I could make for a AND gate. I don't know really what's going on there. Next up, we got an OR gate. So right now both A and B are low, and then out is low. You can see down there in this little area. We put A high, and then out becomes high. Put B high, out remains high, and then B high alone, out still remains high. So that was question 3. And then for question 4, the multiplexer, here is the selector. Right now the selector is high, so B is going to be the main selected component. You can see B is low, that means that the out is low. If I make B high, the out does not become high. That's not good. Maybe if I run it or something. Oh, there we go. Boom, I forgot to run it. The V becomes high, or out becomes high, B is high. And then if I have a B as a low, becomes low again. Change the selector to select A by making it low. So we see A is low, the out is low, and then we turn A high, and then the out becomes high. Here is my circuit lab thing. Use the full schematic. If you start sim, it's high because the selector is on A and A is high. Move the selector to B, and then let's have B. It's gonna be low because B is low. Turn B high, and start again. Now it's high. I'm kind of low on time, so I'm gonna do this quickly. The other like truth table things. This is low. I'm tight on time, and you saw the main thing. So yeah, that's about it. Okay, so here's my little circuit. It's a kind of a mess, but you know, it works. Right now, both A, B, and the selector are low, which would mean that the LED is low. When I turn B to be high alone, it's still low, like the truth table says. When I have A and B high, and S low, it is a high. And then when it's just A as a high, it is also a high still. And now for when the selector is high, selector is high, the LED is low. If we have just A and the selector as a high, it'll also be low. When all 3 of them are high, come on, the LED is on, all 3 are high, and when just B is a high, it is still high. Or when B and the selector are high, it is still high. So here is question number 3. This is it blinking at a frequency of 10 Hertz. The green pin is in the negative, so it's using the yellow. And then when I move the green pin to the positive, it's gonna use the blue now at a frequency of 0.5 Hertz. And here is my code. It's a really ugly, like, delay, like, switch these, and then every 1 second you're switching that. So 1 cycle of the 8 will take 2 seconds.